So template parameters specified on this list, or here, we had only one template parameter. They can be of different types, and they can also use primitive integral types which have to be supplied with constants. In our case, it can be extremely beneficial if we could basically take this storage size. By the way, it used to be the container size, but I decided to rename it to be a storage size because it really describes the size of this internal storage and not the size of the container, because container could have different logical size, but could be small, could be larger, but still use the same storage. So this is really just internal storage size. So here the idea is that maybe we can take the storage size like this and make it another parameter, storage size, and we can even specify the default value that we want to use. And then with this type of container, which now is asking to provide the value type of the elements that it wants to store, in addition to this, it's now asking the client side of things, the user who is using this container, to provide the size or use default size that may be 10, or we may choose what this default storage size is. So I'm just giving you an example where parameter lists can be expanded. And as we discussed before, then every time we create a new container like this, right? So we create this container of doubles, container number 2 container of doubles, container underscore s, which is container of strings right here. Every time we do this, we could use the default size, or we could add different, like we could enlarge it to 100 or 1000 and so forth. So the user has the flexibility to provide a constant size of this container. So there's a limitation on the primitive, also known as non-type name or non-class arguments on the list of template parameter lists. They have to be constant, and they have to be of primitive data type, integral data type. So there's a limitation on them. Okay, so I decided, instead of very tediously making all changes, I decided to put together a sample of this already converted to the version that uses storage size as a template parameter. And I have it here for you to look, and this is just like we started here. I just brought it up, loaded into my browser, because here I just want to highlight the storage size that we now adding here. So this line of code is really right here. This is the line of code, and of course this is my web browser, so it's not highlighting the syntax, but that's a good thing, because what I would like to do is I would like to highlight everywhere where this would have to be changed. You can see that as soon as you're adding new template parameter to the list of your template parameters, and you already have some code written already, like we did have it here. Look, every time we've used value type, now we must add the second parameter, storage size, right? So this is a little bit tedious, and it's always tedious and difficult task to program every single detail of a template, template classes and template functions, definition of template definition of member functions of template classes, and so forth, right? And this way we can satisfy the main program and be able to change the sizes of our containers. So basically every time we said container value type, now the new element is added to the syntax. So it's not exactly very mechanical change. There was some other changes that I had to make. For instance, I was glad that I kept this old storage size, a private data member, And so I decided to keep it and renamed it as a size, and kept it, just initializing it with this new storage size template parameter, which is just another integer right here, which is like, positive integer, and the default size I kept at 10. I really haven't changed this, but I moved it outside of our class and placed it as one additional parameter of our container class. So anyway, what I'm about to do, I'm just going to copy and paste all of this. Okay, I just have this entire code written here, and show you that basically, again, from the client standpoint, not a lot is going to change. It's the same code, and that's the idea. We want to keep the same code running just fine, but if we make changes like this, of course the code, the implementation code for our templates changes. So Control A to select everything, Control C to copy, and here I'll just Control A, select everything, delete, and paste. So this is brand new version, but this time with the storage size in place, and I added some comments as we made progress through our slides in this series of presentation. So I'm just going to build this. Okay, so I'm building it, and now I would like to run it, and here you can see that I reduced the size of the container to 6 elements, and we're still populating the 5th element. The main function is now slightly different. It's using integers in this example, but it doesn't matter. You can pretty much copy and paste the previous version of the main function into this demonstration, and see the entire code work exactly the same way. But now we just moved this storage size to be yet another template parameter. So once again, it's a tedious process, and all intricacies of template syntax would have to be explored by you, and it's going to take perhaps another 2 to 3 months to get everything together in terms of the little important things and rules to know about templates, instantiation, and the rules about template specialization, and there is a lot of various things that we're not covering in this presentation, but it requires another course to talk about these features. So yeah, so this is almost all that we're going to cover right now. So I show you these things by example in our stage of exploring features of C++.